All right, guys, so we are going to finish up our trig unit here with 5-9. I'm going to at least get you started. I don't want this video to go too long, so I'll get you through what I can, and then we'll finish up in class. But I do want to introduce it to you. After 5.8, this one won't be quite as just extensive as 5.8 because now that you've been using some trig formulas for the sum and difference formulas, these double angle, half angle formulas will feel a little familiar to you. So the sum and or the half angle, double angle formulas come in use the same way the sum and difference formulas do. So if I'm asked to find an angle, the sine or some trig value of a unit circle or of a rotation that's not on a unit circle, but that is the sum or difference of two unit circle values, that's where those come in handy. Same with double and half angle. So I might be asked for a unit circle trig ratio value of an angle that's not on here, but is maybe half of an angle that on here. So for example, pi over 12. So pi 6 is here. Half of that is pi over 12. So we don't have a unit circle value there. However, since I know the information about pi over 6, the half angle formula would help me. So we see, you'll see on this page, obviously, the half angle and double angle identities that are given to you. I am just going to very quickly show you where they come from. It's not something that you're going to need to replicate, but it does help to know just where some of these things come from. So hold on, let me time myself because I don't want to go too long. Okay, so this double angle identity comes from the sum identity that we did in class for 2.8. So the cosine of 2 theta, if we look back at our double angle or our sum formula for cosine of alpha plus beta, we'll just apply this. The only difference here is that alpha and beta happen to both be theta, which would be the same exact value or angle. So applying this to my sum formula for cosine of alpha plus beta, I would have cosine of alpha, which is theta, times cosine of beta, also theta, minus the sine of both of them, so sine of theta times sine of theta. So obviously this is just the cosine squared of theta minus sine squared of theta. And that's the first form of the double angle formula for cosine. So there will be 3 forms of this exact identity. So the first one is cosine squared minus sine squared. Again, that comes directly from our sum formula for cosine. So this is the double angle formula for cosine. And then we've got 2 sort of iterations of this because now a lot of you might be looking at this and thinking that this equals 1 because the Pythagorean theory or the Pythagorean identity, but that actually says that cosine squared plus sine squared equals 1. So when you throw that subtraction in there, it's not the same as 1. But I do know that because of our Pythagorean identity, I can replace cosine squared and sine squared with 1 minus the opposite 1. So because this is like the main double identity for cosine, but this also generates 2 other identities. And that would be if I replace cosine squared with 1 minus sine squared, or if I replace sine squared with 1 minus cosine squared. So this is going to give us 2 other identities. And I'm not going to walk through the simplification steps. I'm just going to show you the result. So the second one would be that cosine of 2 theta, all in terms of sine, would be 1 minus 2 sine squared theta. And the other option for cosine of 2 theta is 2 cosine squared theta minus 1. So these are the 3 different options when we are looking for the cosine of double of a unit circle value. Now you can choose any of these. Obviously, if you have both the cosine and sine of theta, you could choose the first one, but let's say you only have the sine of theta, then you could choose this. All of these are listed right here, these 3. So you see, these are the 3 cosine double angle identities. There's just one sine and one tangent. So we could apply the same process to find the double angle for sine. So plugging directly into the formula for our double angle or our sum identities, sum and difference identities of sine of alpha plus beta, that would look like the sine of theta times the cosine of theta plus the cosine of theta times the sine of theta, coming directly from the 5.8 notes. And then if you really think about this, this is just the same thing. Sine squared, or sine times cosine plus cosine times sine. That's just two of those, sine theta, cos theta. So that is where this sine 2 theta 2x comes from, 2 sine of x times cosine of x, directly from our sum and difference identities. Okay, so, and then we see these half angle identities, and I'm not gonna derive these for you. And again, like I've already mentioned many times, you don't have to memorize any of these, just know how to apply them. We're actually gonna start with half angle identities. And again, the example I gave you, which I think is a good way of kind of remembering why we're doing this, is I have unit circle trig ratios for all of these, but like I have pi fourths, but half of pi fourths, if I take that and divide it by 2, would be pi over 8. I don't have pi 8s, but if I know the information about pi over 4, then I can find the information about half of that as well. So it makes it useful in finding missing information. What I want you to do first is actually flip to the very last page of your notes. We're going to actually start with examples 5 and 6, and then we'll go to the previous page and work through example 3, which is kind of going to like tie everything together. Okay, so starting with example 5 and 6, applying the half angle identities. I'm going to keep this, my formula page, handy so that we can reference it. Okay, use the half angle identities to find cosine of pi over 12. In order to find use the half angle identity, you need to figure out what is pi over 12 half of. So I'm looking for cosine of pi over 12. I'm going to be using this formula, cosine of x over 2. I need to figure out what is pi over 12 half of and rewrite it like that. So I want to write this as some unit circle value that I know about being divided by 2. So pi over 12 is half of pi over 6. So this is kind of like the unsimplified way of writing that. So pi over 6 is the unit circle value that I do know. So in this case, this is representing the x, the pi over 6 here. And then in the formula, notice I'm not using pi over 12, I'm actually just using pi over 6. So I'm going to apply this formula. So the cosine of pi 6 halves, so again, pi over 6 is like the x right here. That is the positive or negative, so we're going to have to figure out which one it is. 1 plus cosine of x. Now my x in this case, like I mentioned, whatever it is, whatever unit circle value that's being divided by 2, pi over 6, all divided by 2. So I've just plugged this formula in. So let's determine if that's going to be the positive or negative, because that's definitely something I'm going to need. So think about where pi over 6 is. We know that's actually like our first unit circle value. Obviously, that is in the first quadrant. Half of that, so pi over 12, is also in the first quadrant. So think about the value of cosine right here in the first quadrant. That is going to be positive. So you do need to stop, think, and reason through to figure out for all of these half angle identities, is it going to be the positive or is it going to be the negative root? All right, so now that I have established that it's going to be positive, I'm going to actually write the cosine of pi over 6 in. So it's the positive square root of 1 plus the cosine of pi over 6. So again, looking at my unit circle, finding pi over 6 right here, and the cosine of pi over 6 is root 3 over 2. So now I can just write it as 1 plus root 3 over 2, all over 2. So now we just need to simplify. This is not very pretty looking. It's got a lot of fractions and multiple roots. So the first thing I would do is let's focus on simplifying these fractions within the fraction. So you would find the common denominator between all three of these terms, which is just 2, because I see that in this fraction right here. I'm going to multiply everything inside this square root by 2 over 2. So what's going to happen is, so this big square root is just along for the ride. 2 times 1 is 2, and then 2 times root 3 over 2 is just root 3. And then in the denominator, 2 times 2 is 4. Now, again, with roots, you can separate numerator from denominator, and 4 is a perfect square. So that's actually just going to simplify to 2. But the numerator is still the square root of 2 plus the square root of 3. That's probably going to make you feel a little uncomfortable because you've got a square root under a square root, and that is actually fine. So this simplifies to this funky looking expression, the square root of 2 plus the square root of 3 over 2. It's just a lot of simplifying. Once you find out how to apply the formula, you're just simplifying a lot of terms. So that's an example of using the half angle identities. I'm going to walk you through another one here, example 6. Use half angle identities to determine or to find the sine of 3 pi over 8. Just like we started here, first we need to figure out what is the value on the unit circle that this 3 pi over 8 is half of. So again, I don't have 3 pi over 8 on my unit circle, but this is exactly half of another unit circle value. Just a reminder, here is my sine formula for the half angle. So I'm using this. If you look at what we just used, which is cosine, it's super, super similar. The only difference is that with cosine, I'm adding. With the sine of the half angle, I'm subtracting, but notice I'm still using the cosine function within the formula. So we need to figure out what 3 pi 8 is half of, and you literally just take half of the denominator. So this is actually the sine of, again, I want to think of it in terms of something being divided by 2, and that something is what my unit circle value is. So that is 3 pi 4ths. That's the x over 2. So I'm taking the sine of this whole thing. Again, it feels weird because I'm complicating the way this is represented, but I want to identify the theta value that's on my unit circle. All right, now applying the formula here. So this is going to be what I'm using here, and where I see the x, I'm plugging in 3 pi halves. So the sine of 3 pi halves is the positive or negative square root of 1 minus the cosine of 3 pi over 2, all divided by 2. I like to determine that plus or minus first, just kind of get that out of the way. And it all comes down to where our value of theta is. So our unit circle value is 3 pi over 4, which is right here. Now, where is half of 3 pi over 4? Think about what the sine value would be. So we're working with sine, and I want to know where half of this would be. It's definitely up here in the first or second quadrant. So just that alone, I don't know exactly where half of 3 pi over 4 is. I could eyeball it, probably somewhere over here. But the fact that I'm just above the horizontal axis here tells me that the sine is going to be positive. All right, so then I'm just going to fill in the rest of what I have. So this is the positive root of 1 minus the cosine of 3 pi over 2. Wait a second. Sorry, guys. I just did 3 pi over 4, not 3 pi over 2. So if you're wondering what the heck I'm talking about, I'm so sorry. I wish I could pause and rewind and re-record, but I can't. Okay, so hopefully you caught me on that. Half of 3 pi over 8, I think I said it, you just take the 8 and divide by 2, is 3 pi over 4. So sorry. Which is why I kept pointing to this one, 3 pi over 4. So that my spot was correct, I just wrote the wrong number there. So half of 3 pi over 8 is 3 pi over 4. We're finding the half angle of 3 pi over 4. So we're still up here in the top, our sign is positive. Okay, back on track. So 1 minus the cosine of 3 pi over 4, that's negative root 2 over 2. So 1 minus negative root 2 over 2 all over 2. I'm going to do the same thing we did up here, which is get rid of these complex fractions. So we're going to, let me see how much time I have. Okay. Multiply everything by the common denominator. So in this case, that common denominator, again, is the whatever denominator I have in this fraction right here. So I'm going to multiply everything inside by 2 over 2. In doing so, we end up with 2 times 1, which is 2. And then this minus a negative, I'll just rewrite that as a plus. And then 2 times root 2 over 2 is just root 2, lots of 2's, all over 2 times 2, which is 4. Okay, so we've got a lot going on here. But again, 4 is a perfect square, so I can just rewrite the denominator as the square root of 4, which is 2. And then my numerator is just the square root of 2 plus root 2. So again, it feels a little funky probably to you to be writing a square root within a square root, but I promise you it's okay. And that's it. So this is the exact half angle, or the exact value of sine of 3 pi over 8 after we use that half angle formula for 3 pi fourths. So this is just a walkthrough of half angle identities. I do want to get us started, and then I'll probably finish in class on the problems before this one, which would be example 3. So example 3, I need to keep an eye on my time here. So example 3, you're given cosine of theta. You're told where it is on the unit circle. So we don't know where theta is, but we are being told it's between pi and 3 pi halves. So remember, this is pi, this is 3 pi halves. This is 1 pi half. Okay, so between pi and 3 pi halves. So our value of theta is somewhere right here in quadrant 3. Cosine is negative 3/5. Now, the first thing here is complete this. So if theta is between pi and 3 pi halves, we need to know where 2 theta is, because I'm going to be finding information about, I'm going to be using these double angle identities. But because I'm also using these half angle identities down here, I'm also going to need to know where half of theta is. That part is really simple. All you have to do, if we have this relationship right here, if I want to know where 2 theta is, all I need to do is multiply both of those sides by 2. So it's kind of like an equation. If I want to know where 2 theta is, to get 2 theta, I would multiply every piece of this inequality by 2. So that means 2 theta is between 2 pi and then 2 times 3 pi over 2 is going to be 6 pi over 2, which is 3 pi. So 2 theta is between 2 pi and 3 pi. Think about where 2 pi is right back here. 3 pi would be right in the same spot as pi. So it's right here between 2 pi and 3 pi. You could also think of it as being between 0 and 2 pi. Then I want to figure out where, now the reason we're doing this is because down here where I'm finding double angle values, I'll need to know where 2 theta is, which is up here in the positive. So that's going to give me a positive sign. Now I want to know where half of theta is, and it's determined using the same process here. If I know this information, then all I have to do is divide every piece of this by 2, and then I'll know where, or multiply by 1/2. Then I'll know where half of theta is. So half of theta is between pi over 2 and 3 pi over 4. I'm going to be referencing this information later on when I get down here to find these half angle values of theta. Okay, so the first thing on our list is determine sine and tangent. Once we have these, then we'll be able to find more information using our formulas. Sine and tangent just come from our normal identities that we're already familiar with. So that's going to come from the Pythagorean identity for part B. Tangent, since we know tangent is sine over cosine, we'll be able to find that after we find sine. All right, so I know that sine squared theta equals, sine squared theta plus cosine squared theta, so cosine is negative 3/5 squared equals 1. So sine squared of theta equals, no, sine squared of theta plus 9/25 equals, and here's where I rewrite 1. I'm going to rewrite 1 as 25/25. Now I can easily subtract 9/25 from both sides. So the sine squared of theta equals 25/25 minus 9/25, which is 16/25. Then I'm taking the square root of both sides and get that sine theta equals the positive or negative square root of 16/25, which is 4/5. Okay, so we need to figure out if it's positive or negative. Again, it comes right back here to where theta is. I'm just looking for the sine of theta. Since theta is right here, the sine is negative. So my sine of theta is negative 4/5. The tangent of theta, well, we know tangent is the same as sine of theta over cosine. Sine of theta we just determined was negative 4/5. Divided by the cosine, so negative 3/5. I'm just going to multiply by the reciprocal of that, negative 5/3. So the good thing is the 5's cancel, and then I just have a 1 left up here. So negative 4 times negative 1 is 4, and then this is just a 1 times 3. So the tangent of theta is 4/3. All right. Now, to apply a double angle, I'm just going to do D, and then I'm going to finish the rest of this in class with you. So double angle formula. So I have information about theta. I know the cosine of theta. Now I know the sine of theta. I know the tangent of theta, and I know where it is. Cosine of 2 theta. So I'm going to walk you through this. We have 3 options for this formula. Do I want to use the double angle formula that is cosine squared minus sine squared? We could use 1 minus 2 sine squared or 2 cosine squared minus 1. It doesn't matter what you choose. Because we know both the cosine and the sine of theta, now that we just did that, I'm just going to go ahead and use this top formula here. So the cosine of 2 theta is the cosine squared theta minus sine squared theta. I'm just directly applying my formula right here. Cosine of 2 theta. Now, I know cosine and sine, so I can just easily find their squares. Cosine squared, so negative 3/5 squared, minus sine squared. We just found sine to be negative 4/5. And then I'm going to square each of these. So negative 3 squared is positive 9, 5 squared is 25, minus negative 4 squared is 16. Sorry for all my errors today, yikes. Okay, that's negative 4/5. 5 squared is 25. And then I simplify. They have the same denominator, so just subtract. 9 minus 16 is negative 7/25. That is the exact value of cosine of 2 theta. Even though we don't even know what theta is, we know the cosine and sine of it, so we now know the cosine of double of whatever theta is. Okay, so that's how simple applying the double angle formulas are. If you know the cosine and sine, you can find cosine of 2 theta. I'm going to stop here. We will pick up here in class, so make sure you bring this with you, post what you have, post pictures to the assignment on Schoology now so I can make sure you've gotten this far, and then we'll finish up in class together. All right, y'all, I will see you soon.